In this section, we're going to talk about shifting graphs, stretching and shrinking graphs. And before we start talking about the rules of translations of graphs, I first want to refresh your memory on what I like to call the mother functions. These are all the basic functions before they start getting shifted. So the first function I want to review with you is just the constant function. Y is equal to some constant. So y is equal to 2, y is equal to -5. Whatever that value is of c, that's where it's going to cross through the y-axis. So for example, if we have y is equal to 2, it would pass through 2 on the y-axis and just be a horizontal line. Okay, the next function I want to review with you is just a linear function. Just y equals x. Let's actually do this in a different color so it's easy to tell the difference between the function and the axes. So this is just your mother function, your linear function, y is equal to x. The next function I want to review with you is quadratic. This is a degree 2 polynomial. It has this kind of a shape, and y is equal to x squared. Then we have the absolute value function, which is a V shape. And this is just y is equal to the absolute value of x. Okay, next one is a cubic function. This is a polynomial of degree 3. And this is the equation y equals x to the third. The next mother function would be the reciprocal function, which would look like this. My hand isn't very steady, but I'm trying not to, but it would never touch the x or the y axis, but it would get really close. And the equation looks like this. So whatever your value of x is, the function takes the reciprocal and then it graphs that for y. So you would have the 0.2 and then 1/2 for y, for example. Okay, and the last two functions I want to go over with you is the square root function, which looks like this. It has an arch shape to it. It starts at 0, 0, and it has an arch. This is y is equal to the square root of x. And then we have the cube root function, which looks like this. That's the cubed root of x. So all I expect you to do for these functions is to just recognize the shape of these. So if I give you a graph that has an arch shape, which starts at 0, 0, or some other point, and it could be shifted, that's what we're going to talk about. But if I give you a graph that has an arch shape that starts at one point and then it arches up and then it has an arrow at the other end, you should recognize that as being a square root function. Or if I give you a graph that has a smile shape, you should recognize that as an x squared function. Or a V shape, you should recognize as the absolute value of x function. So that's all I want you to do with these, is just be able to recognize the shape. Okay, now we're going to get into the actual rules of graph shifting. So if I have a function, f of x, and I just add some constant to it, then this is going to be a vertical shift up c units. So for example, if f of x is x squared and I add 2, then that means I take my mother function of x squared and everything gets bumped up 2. F of x minus c is a vertical shift down C units. So if I had x squared minus c, that means I would take the x squared function and bump everything down 2 places vertically. Now notice that the plus and the minus c is on the outside of my function. I'm adding it to the entire function. When I add a value to x or subtract a value from x, that is when I'm doing horizontal shifting. So you got to be able to recognize the difference. When you're adding or subtracting a value, the first thing you want to recognize is that's going to be a vertical or horizontal shift. If you're adding or subtracting it to the x, it's going to be a horizontal shift. And if you're adding or subtracting it to the entire function, then that's going to be a vertical shift. Now, the x's are a little bit different and a little bit anti-intuitive. If I see that I'm adding something to my value of x, then that actually means I'm moving to the left C units. So this means a horizontal shift left C units. So for example, if we used x squared and I replaced x with x plus c and I wrote it like this, that means I'm doing some kind of a horizontal shift depending on what my value of c is. If, for example, my c is a positive 2, then I know I'm taking the entire graph and moving it to the left 2. When I see that I'm subtracting something from x, then that means it's going to be a horizontal shift to the right C units. Now, in the next 2 examples, if I multiply a number by the function or by x, then that means I'm going to be doing a vertical stretch or shrink or a horizontal stretch or shrink. So in that case, the shape of your graph might change a little bit, whereas the 4 previous examples, or the 4 previous rules, were actually just picking up the entire graph and moving it up or to the right. We're not really changing the shape of it, we're just moving everything over, or up or down. So when we are multiplying a value, that means we're doing some kind of a stretch or a shrink. Now when the c or whatever it is that you're multiplying by is being multiplied by the entire function, then that means it's going to be a vertical stretch or shrink. Now you can tell if it's a stretch or a shrink. If c is greater than 1, it's going to be a stretch. And if c is between 0 and 1, like a half or a third or something like that, then it's going to be a shrink. If the c is being multiplied by the x only, not the whole entire function, but just by the x, then that's going to be a horizontal stretch or shrink. Now again, the x's are a little bit backwards. If c is greater than 1, then it's going to be a shrink. Let me write this in a different color so it's easy to read. We're kind of running out of space here. So if your c is greater than 1, it's going to be a shrink. If your c is between 0 and 1, so for example, a half or 2/3 or something like that, then it's going to be a stretch. Okay, last concept. If you see negatives in there, like a -1 times something, if you take a -1 times the f of x, that means you're changing the sign of your y value. And when you change the sign of your y value, that means it's going to be a flip or a reflection across the x-axis. If your -1 is being multiplied by the x only, then all the signs of your x's get swapped, which means that's going to be a reflection across the y-axis. So these are all your rules. Once we start going through some of these, it will make more sense, and these definitely take a lot of practice. And you have to be very comfortable with function notation.